Hey, hello everyone. Welcome to this channel, and today we are going to solve LeetCode 322, which is a coin change problem. It's a famous dynamic programming problem. Here we have given coins array which contains 1 to 5, and the amount is 11, which asks that the minimum number of coins that we need so that we can form the sum 11. Alright, here the minimum number of coins needed is 2 times 5 plus 1. Total 3 coins are needed to form the sum 11. Here the minimum number of coins required to form the sum 3 is it cannot be formed using 2. Either it should have 1 or 3. So here we will return minus 1. So the question is clear. We haven't given an integer array coins representing coins with different denominations, and the integer amount representing total amount of money. So we have to return the fewest number of coins that you need to make up that amount. Alright, so this problem comes under dynamic programming. As you can see, I have already tried previously. Okay, so here basically all problems under dynamic programming comes with the concept of uh, a temporary array, DP array, either 2D or 1D based on the problem. And here we need 1D array, and here basically we will think of as the given amount is 11, and we have to think of how we can form the sum 1 or 2, 3, 4, and slowly we will reach the desired amount 11. So we have to follow this using bottom up approach. Okay, approach. And here in order to follow this, we have to have two for loop, which will be 1 and I equal to 0, which will be basically from 1, I is less than amount, and I plus plus. Well, I should be less than or equal to amount, because amount is the desired sum which we have to return using the coins inside the coins array. And inside this for loop, we will iterate for the coin array, and j is equal to 0 from the first index, and j is less than coins dot length and j plus plus. So to have the calculations stored, we have to have a temporary array which we will call tp. Let's continue, and here we will give the size of this tp array as amount plus 1. So this tp array basically stores all the previously calculated number of coins required to form the sum 1 or 2 or 3 or 4, and slowly we will reach 11. And the benefit of the TP array is we need not to recalculate this sum. We will use the desired pre-calculated value stored in TP array, and use the logic to get that value and get the minimum number of coins required. So in order to have that, we have to fill this TP array with integer dot max value. All right, and then here inside the loop, we have to check with the condition if I, which is the sum, is greater than or equal to uh, coins of j. In this case, the TP array which we have calculated, which is the ith value, will be math dot minimum value for either the previously calculated the TP value, or the um, value which is formed using I minus coins of j. So coins of j is basically uh, which is already calculated. Coins for I mean dp of I minus coins of j is value something which is already calculated. So if we do have that value, we just need one additional coin to form the sum amount. And if we don't have, we will have the max value, and still it will store the minimum value. We are using math.min. And why it will have the max value? Because we have already filled all the DP array values with max value of size amount plus 1. So here it goes, just store the DP of I, this is to for loop, and coming outside for loop, it will check that the DP of amount, which was the question, is equal to um, integer dot max value, then it will return -1, else it will return, if it doesn't, it means it has been calculated, it will return DP of amount. But here is one additional trick which we can use is here there is a possibility that the DP of I minus coins of j might contain the maximum value, so we need not to come under this if condition in that case as well. So if DP of I minus coins of j, I minus coins of j is not equal to integer dot max value, if it is not equal to this, it will come under the if condition, it will calculate the DP value. So the logic is simple. Let us first run to check. Okay, if I is greater than equal to coins of j and the DP of I minus alright, not equal to integer dot max value. Alright, so here DP of amount is okay, we have to return. Okay, we have wrong answer for first, expected -1, expected 3, returning -1. So if DP of amount is equal to integer dot max value, it is -1, else it will be DP of amount. And it goes here we have to have initial value, because uh, for I it's starting with 1 and we are using DP of I minus 1, which is negative, and for DP of 0 it should be 0. I think that could be the reason here for failing. DP of 0 is equal to 0. My bad. Again, two test cases are passing, one is failing, and here is expectation 3. Output is -1. Let's look again into here. Amount plus 1 is the size of DP. DP is integer dot max value. DP of 0 is equal to 0. I is equal to 1. I is less than equal to amount. J is equal to 0. J is less than coins of length. J plus plus. If I is greater than or equal to coins of J. And DP of I minus coins of J is not equal to integer dot max value. Then DP of I is equal to math dot minimum value. DP of I and DP of I minus coins of J. Okay, here it goes, plus 1. Alright, so this is passed, and let's submit and check whether all test cases are being passed or not. Alright, so here it goes. So the logic was simple. It was to use a temporary array, DP array, to store the minimum number of coins required to form the amount 1, to form the amount 2, to form the amount 3, until the time it gets the value for 11. So the outer loop iterates on this values of amount, and the inner loop iterates for the coin array, and inside we check the condition to get the minimum value for DP of amount, and the DP of amount minus the coin value, which is whatever it is. I mean, I think it was 1, 2 and 5. So keeps on iterating and keeps on checking the minimum value and keeps on updating for the amount value. So for each amount, it is iterating based on the number of coins in the coins array. So suppose we have 3 coins in the coins array, so as per this, it will iterate internally 3, and the outer loop will iterate till the time the amount is reached. So thank you everyone for this. It was a beautiful problem of dynamic programming. See you again.